China has always been known for making things fast and making things cheap. But in 2026, China is doing something that nobody expected. They are replacing aluminum, one of the most important materials in the entire car industry, with technology so advanced it sounds made up. A company called Xiaomi, which most people know for making phones and gadgets, just built a car chassis that makes traditional aluminum look like a toy. This is not a small upgrade. This is a complete replacement of how cars have been made for 100 years. The technology is so insane that other car companies are scrambling to figure out what just happened. Xiaomi used artificial intelligence to create a brand new metal from scratch. They built a machine the size of 2 basketball courts to shape it, and they turned the battery into the actual bones of the car. The result is a car called the SU7 Ultra that just ran the Nürburgring racetrack in 6 minutes and 46 seconds, beating a Porsche by several seconds. If you are enjoying this video, please hit the like button because it takes a lot of effort to put these together. And subscribe so you do not miss the next one. What you are about to see involves 10 million computer simulations, a metal that skips the oven entirely, and a car body so stiff it beats a Bugatti. To understand how China pulled this off, you need to start with a simple question. Why did the old way of building cars stop working? Why old car building stopped working? Think about how a house is built. You take bricks, you stack them, and you stick them together with cement. Every brick is a separate piece. Every line of cement is a connection point. The more pieces you use, the more places there are where something can go wrong. Cars have been built the same basic way since the 1950s, but instead of bricks, they use flat sheets of steel pressed into shapes by giant machines. Then workers weld all those shapes together. A normal car has hundreds of separate steel parts joined by hundreds or even thousands of welds. Think about it like building a Lego tower. Every time you connect 2 pieces, that connection is a spot where the tower can wobble. If you have 10 pieces, you have 9 connections. If you have 300 pieces, you have 299 connections. Every single connection is a place where things can shake loose over time. In a car, every weld adds weight. Every weld can let noise sneak into the cabin where people sit. Every weld is a spot that might weaken after years of driving on bumpy roads. Smart people have spent 50 years trying to make this process a tiny bit better. They shaved off a few grams here and there. They made the welding slightly faster, but the basic idea never changed. You still stamp pieces of metal and weld them together. Then electric cars showed up and made everything harder. An electric car needs a huge battery to power its motors. That battery is heavy. Where do you put it? The floor of the car seems like the obvious spot, so you bolt this giant heavy box underneath the floor. But now the car is heavier, which means the frame needs to be stronger to hold the extra weight. A stronger frame is heavier, which means you need a bigger battery to move the extra weight. A bigger battery is heavier, which means you need an even stronger frame. You can see where this goes. It is a loop that keeps making everything heavier and more expensive. Tesla saw this problem and tried something smart. They stopped stamping dozens of little steel pieces and welding them. Instead, they poured melted aluminum into giant molds to make big single pieces of the car. They called it Giga casting. Instead of 60 separate parts joined together, you get one big piece straight out of the mold. This was a big deal. Fewer pieces means fewer joints. Fewer joints means less weight and faster building. But here is the thing. Tesla's idea had a giant hidden flaw. A flaw so big that every other car company tried to copy the idea and failed. And that flaw is exactly where the story of Xiaomi and China's insane new technology really begins. Because the problem was not with the machine or the design. The problem was inside the metal itself. The hidden flaw inside every cast car part. When you pour hot liquid aluminum into a mold, something strange happens as it cools down. The outside looks solid and perfect, but deep inside, at a level you cannot see with your eyes, the tiny structures that make up the metal are all mixed up and pointing in random directions. Think of it like a pile of pickup sticks dropped on the floor. They are all jumbled and pointing wherever they fell. The metal looks solid on the surface, but those jumbled internal structures make it weak when you push on it hard enough. The way car companies have always fixed this is by putting the metal part into a giant oven. They bake it at very high heat for many hours. The heat forces those tiny internal structures to line up in neat rows, like soldiers standing in formation. This makes the metal much stronger. Think of it like cooking raw dough. The dough is soft and weak until you bake it. Same ingredients, totally different result after the oven does its job. So far so good, right? But here is the part that ruined everything for every car company that tried to copy Tesla. When you bake a giant, complicated metal part at extreme heat, the metal does not just get stronger, it also bends. It twists. It moves in tiny ways that you might not notice looking at it. But in a car, even a tiny shift is a huge problem. Think about a door frame in your house. If the frame shifts even a few millimeters, the door will not close right. The lock will not line up. The whole thing becomes a mess. In a car, if the chassis shifts during baking, the doors will not close properly. The wheels will not sit at the right angle. Parts that are supposed to fit together perfectly will not fit at all. This left car companies with two terrible choices. They could skip the oven and get a part that was the right shape but too weak to be safe. Or they could use the oven and get a part that was strong but bent out of shape. Either way, they lose. Every major car company in the world tried to solve this. Some of the biggest names in the business spent years and millions of dollars researching it. Toyota, BMW, Ford, you name it. Every single one of them hit the same wall. Most of them just gave up and accepted the problem as something they had to live with. They built their factories around the flaw and moved on. In the car industry, this became known as one of those problems that nobody talks about because nobody has an answer. Then Xiaomi walked in. They looked at the same problem that stopped every other car company on the planet, and they said no. They were not going to accept it. Their engineers checked every single aluminum mixture that existed. Not one of them could do everything they needed at the same time. They needed something strong, something flexible, something that held its shape, and something that did not need to go into an oven afterward. The perfect metal for this simply did not exist anywhere in the world. So Xiaomi made a choice that sounds crazy. If the metal they needed did not exist, they would invent it themselves. And the tool they used to do it is something no car company had ever tried before. How AI created a metal that never existed. This is where the story takes a turn that sounds like science fiction, but is happening right now in a factory in Beijing. Xiaomi built an artificial intelligence system and gave it a name. They called it Material Genome. Think of it as a scientist that works at the speed of light. This AI never sleeps. It never gets tired. It never needs a coffee break. It can run millions of experiments at the same time, all inside a computer. Xiaomi fed this AI every piece of information that humans have ever learned about metals, mixtures, and material science. Then they gave it a job. Find a recipe for a new metal that is strong, flexible, perfectly precise, and needs absolutely zero time in an oven after it is cast. The AI went to work. It tested 10,160,000 different metal mixtures in its simulations. Let that number sink in for a moment. If a human scientist mixed one new metal formula every single day, working 365 days a year, with no weekends off and no vacations, it would take more than 27,000 years to test that many mixtures. 27,000 years. That is longer than all of recorded human history. The AI did it in a tiny fraction of that time. Here is a way to picture what the AI did. Think about making the perfect sandwich. You could try different combinations of bread, meat, cheese, and sauce in your kitchen. Maybe you try 20 or 30 different combos over a few weeks. But imagine if you had a computer that could simulate 10 million different sandwiches, testing every possible ratio of every ingredient, every temperature, every timing. The computer figures out the exact one that tastes perfect every time before you ever pick up a knife. That is what Xiaomi did, but with metal instead of food. The AI mixed aluminum with silicon, magnesium, and rare earth elements. It tested them across billions of pretend scenarios. It pushed them, bent them, heated them, and stressed them in the computer world. And it found one single mixture out of all 10 million that met every target at the same time. Strong enough, flexible enough, precise enough, and completely free of the need for oven baking. Xiaomi named this metal Titan's metal. It belongs to them and nobody else. When Titan's metal is poured into a mold and cools down, something amazing happens. It comes out already strong. It comes out at exactly the right size and shape. It is ready to be used the moment it comes out of the mold. No oven needed, no bending problem, no need to choose between strong and accurate. You get both. What this means in the real world is huge. The factory line moves faster because there is no waiting for oven baking. Less energy is wasted because giant ovens use massive amounts of power. The parts fit together more tightly than anything made the old way. The whole system gets better from just one single change at the metal level. But having an amazing new metal is like having an amazing new recipe. You still need a kitchen big enough and powerful enough to cook it. And what Xiaomi built next is a machine so large and so powerful that people who see it in person can barely believe it is real. The giant machine that prints car frames. When Tesla built their Giga press, it could press with 9,000 tons of force. People who write about cars for a living said it was the most powerful machine humanity could build. When experienced engineers walk into the room and see it, they go quiet. It is that impressive. Xiaomi built a bigger one. Their machine presses with 9,100 tons of force. They call it the Hypercasting machine. This is not just a slightly bigger version of Tesla's machine. The Hypercasting machine is so large that it covers the same area as 2 basketball courts sitting side by side. The machine itself weighs more than 1,000 tons. That is heavier than 3 fully loaded cargo planes. It heats Titan's metal to 700 degrees Celsius, which is hotter than the surface of some planets. Then it shoots the liquid metal into a mold so fast that air does not have time to get trapped inside. Why does that speed matter so much? Think about pouring juice into a glass. If you pour slowly, bubbles form as the liquid hits the sides. Those bubbles are harmless in juice. But in metal, trapped air bubbles are like hidden holes inside the part. From the outside, everything looks perfect and solid. But deep inside, those tiny air pockets are weak spots. When a fast car hits bumps and takes sharp turns at high speeds, those hidden air pockets can turn into cracks. And cracks in a car frame are bad news. By injecting the metal so fast that bubbles cannot form, Xiaomi makes parts that are solid all the way through. Every tiny corner of every piece is packed tight with metal. This level of solid density is something you normally only find in parts made for airplanes and spacecraft, not regular cars. Now let us look at what this machine actually makes. The rear floor of a car is one of the most important structural pieces. In a normal car, that section is built from 72 separate steel parts. Those 72 parts are held together by 840 individual welds. Every single one of those 72 parts has to be made separately, shipped to the factory, stored on shelves, picked up by workers, lined up perfectly, clamped in place, and welded one at a time. The whole thing takes hours and needs a big team of workers and many different machines. Xiaomi's Hypercasting machine makes that exact same section as one single piece in 100 seconds. 72 parts become one part. 840 welds become 0 welds. Hours of work become less than 2 minutes. The single piece is also 17% lighter than the old 72-part version. And because there are no tiny gaps or imperfect welds rubbing against each other, the car is 2 decibels quieter on the highway. That might not sound like much, but 2 decibels is the difference between a calm ride and a noisy one on long trips. After each piece comes out of the machine, the checking process is just as impressive. Every single piece gets scanned by X-ray cameras and laser sensors while it is still inside the machine. An AI system looks at every piece from every angle in a fraction of a second. If it finds even the smallest flaw, the piece is rejected before any human ever sees it. No human inspector could check that fast or that carefully. A brand new chassis piece rolls off this machine every 90 seconds. But as amazing as this machine is, what Xiaomi did next with the battery is the part that really changes everything about how a car works. The battery that became the car skeleton. In almost every electric car driving around today, the battery is just a big, heavy box. It sits under the floor and does exactly one thing. It stores electricity. It does not help hold the car together. It does not make the car stronger. It is just dead weight that happens to power the wheels. Think of it like carrying a heavy backpack. The backpack is useful because it holds your stuff, but it does not help you walk. It just weighs you down. Xiaomi asked a simple question. What if the battery was not just luggage? What if it was part of the skeleton of the car? What if the thing holding the energy was also the thing holding the car together? This idea is called CTB, which stands for cell to body. Instead of putting the battery in a separate box and bolting that box to the frame, Xiaomi built the battery cells right into the chassis itself. The top of the battery pack is also the floor of the cabin, where passengers put their feet. The battery cells are not just sitting there anymore. They are carrying the weight of the car. They are part of the structure. But Xiaomi did not stop there. They made one more choice that sounds strange at first, but turns out to be brilliant. They flipped every battery cell upside down. Here is why that matters so much. Every battery cell has a tiny safety valve on it. If the battery gets too hot, this valve lets hot gas escape, so the battery does not burst. In a normal electric car, these valves point up toward the passengers. Because the valves point at people, engineers have to put thick layers of protective material between the battery and the cabin. That protection is important for safety, but it makes the car taller and heavier. Xiaomi flipped every cell so the valves point down toward the road, away from the people inside. The car floor itself acts as the protection layer. This meant they could remove all that thick extra material inside the battery pack. The total thickness of the battery and floor together shrank to just 120 millimeters. That is about as thick as a hardcover book you would find on a library shelf. This one change had a huge effect. The car sits much lower to the ground. A lower car has a lower center of gravity, which means it corners better and grips the road harder in turns. And because the battery cells are part of the actual frame, the whole car becomes incredibly stiff and solid. How stiff? The SU7 Ultra has a stiffness rating of 51,000 Newton meters per degree. Here is a way to understand that number. A Ford F-150 Raptor, which is one of the toughest pickup trucks you can buy, has a rating of about 25,000. The Xiaomi sedan is twice as stiff as a truck built to jump over rough ground. It is also stiffer than a Bugatti Chiron, which is one of the most expensive cars ever built. A car from a phone company, using a battery as its backbone, is stiffer than a car that costs millions of dollars. That stiffness is not just a fun number to show off. It is the reason every other part of the car works so well. When the frame does not bend or flex at all, the suspension can do its job perfectly. The tires stay flat on the road through hard turns. The whole car drives exactly the way the engineers wanted it to. And the engineers wanted it to handle 1,548 horsepower from 3 electric motors. Each motor spins at 27,200 RPM, which is a world record for a motor in a production car. Most high-performance electric motors top out at about 20,000 RPM. Xiaomi's motors spin 35% faster than that. Without the new metal, the giant machine, and the battery skeleton all working together, that kind of power would tear a normal car apart. But because everything was designed as one connected system, every part supports every other part perfectly. What this changes for every car company. What Xiaomi did with the SU7 Ultra is bigger than just one fast car. They proved something that every other car company in the world is still trying to understand. Sometimes the smartest way to build something is to forget everything you know and start from zero. Using AI to design a brand new metal instead of making small changes to old metals, that changes the starting point for everyone. Building a machine bigger than any other and using it to replace 72 parts with one, that changes how factories work. Flipping battery cells upside down so the battery becomes part of the frame, that changes what a car even is at the most basic level. China is not just catching up to the rest of the car world anymore. They are jumping past it. The technology in this Xiaomi chassis for 2026 is not a concept or a plan for the future. It is real. The Titan's metal is being made right now. The hypercasting machines are printing chassis pieces every 90 seconds in a factory in Beijing. The CTB battery system is already in cars that people are driving on real roads today. Think about what this means for the future. When you can design the metal, the machine, the structure, and the battery all at the same time, you get something that no traditional car company can match. The old way of building cars, with hundreds of steel pieces and thousands of welds and a battery bolted underneath like an afterthought, is being replaced by something completely different. The new way is to let AI find answers that human engineers would never think of on their own. Xiaomi even showed a concept car called the Vision GT with 1,900 horsepower and aerodynamics so advanced they would not be allowed in Formula One racing. And the crazy part is that this is not science fiction. It is a preview of what they can build right now with the technology already running in their factory. Every serious car company on the planet is paying very close attention to what just happened. The way cars have been made for 100 years is changing, and China is leading the change. Aluminum is being replaced by something better, smarter, and faster to make. And the company doing it is the same one that makes the phone in your pocket. If you made it this far, you clearly love this stuff as much as we do. Hit the like button, subscribe if you have not already, and turn on notifications so you never miss the next one. There are related videos on the screen right now if you want to keep watching. So here is a question for you. Do you think another tech company like Apple, Samsung, or Google could do what Xiaomi just did and build a car from scratch that competes at the highest level? Let me know in the comments.